Hello and welcome to another video. In this video we're going to use a proof by induction to prove that the sum of the square numbers is equal to a sixth n plus 1 multiplied by 2n plus 1. So I'm going to break it down into a three-step process. So I'm going to start with step number 1. Step number 1, what I'm going to do is I'm going to look at what happens if n equals 1. So if n equals 1, my left hand side is just 1 squared, which is 1. And the right hand side is a sixth times 1 times n plus 1, which is 2, times 2 plus 1, which is 3, which also equals 1. Therefore, the first step of the process is true. So therefore, we know it's true for n equals 1. What I'm going to do now is move on to step 2. So step 2, and I'm going to look at what happens if it's true for any number. So we're going to make the assumption, we're going to assume it's true for n equals k. So I'm going to say that 1 squared plus 2 squared plus all the way up to k squared equals a sixth k plus 1 times 2k plus 1. So that is my assumption. I'm going to label that assumption. What we're ultimately aiming for is we want this to be true for n equals k plus 1. We want, if it's true for n equals k, we want it to be true for the next number. So we want true for n equals k plus 1. So if I look at my k plus 1 term, it'll be all the way up to k squared, and then after that will be k plus 1 squared, which equals a sixth. K will become k plus 1. K plus 1 will become k plus 2. And 2k plus 1 will be 2k plus 2 plus the 1, which will be 2k plus 3. So this is now becomes my target. That's what I'm aiming for. So what I'm going to do is I'm going to now use my assumed result, which is up here. So that is my assumption. I'm going to use that assumed result and I'm going to add on the next term. So I'm going to see what happens to this assumption when I actually add on the next term. So starting with this, so sixth k times k plus 1 times 2k plus 1. The next term after k squared would be k plus 1 squared. That's what comes next in this sequence here. So I'm going to manipulate this. First thing I can do is I can factorise out a sixth, and I can factorise out a k plus 1. So I'm going to get sixth, and I'm going to take out a k plus 1. Just so I don't get confused, I'm going to use square brackets here. So I've taken out that and that, which means I'm left with k, 2k plus 1. Now I've factorised out a sixth, which means to restore the balance of that being 1, I need to have 6, and I've already taken out a k plus 1, so only a k plus 1 left. Looking at this square bracket, I can see that that is 2k squared. That term there is going to give me k plus 6k, so I'm going to get plus 7k's, and then number at the end is plus 6. I've got a quadratic. Natural thing to try and do is factorise it, and it will indeed factorise to 2k plus 3 and a k plus 2. And if you now consider what we originally wrote up here for our target, 6k plus 1, k plus 2, 2k plus 3. So here we've ended up with exactly the same term. So adding on the next term has actually resulted what would happen here. So we've reached our target. It matches the target. So it matches the target. Therefore I can conclude with step 3, which says, therefore true for n equals k, it's also true for n equals k plus 1. However, right at the very beginning, we actually proved we know it's true. So for let's consider 1. A question. So therefore, relating to this. So for example, if I had arc cosh 2, n equals, and this would give me 3 log carrying of 2 plus. So we've proved the original statement 3. However, if I was to actually solve the equation, n cosh n plus 1 x equals 2, then in that case I would have x equals plus or minus log of 2 plus the square root of 3.